Let's talk about OEM oil specifications, of which there are many and it's very confusing. So you've got to remember that most lubricant companies exist and one of their primary purposes is to preserve their license to operate. What do I mean by that? Well, they all operate in a regulatory environment, and unless they, act in accordance with those regulations, then they don't get to do business. Now, within the vehicle world, most of that has got to do with emissions, creating cars that meet fuel efficiency standards, which are becoming more and more stringent. However, how they meet those fuel efficiency standards is generally up to them. They can pick any kind of technology stack that they want. So maybe it's a combination of using hybrid plus stop-start plus turbocharging plus some combustion efficiencies. And it could be the case that the standards which are set out by the likes of API, as well as ILSAC, as well as the ASEA group, just aren't going to cut it. It might be that they need the lubricant to kind of give them the edge to get them some more fuel efficiency. Or maybe it's because they have selected certain technologies which have unintended consequences. We've seen the consequences of turbocharged direct injection engines, for example, with LSPI. So all of a sudden, we now need to, attach some additional tests on top of the API, ILSAC, and ASEA criteria so that we can use the technology stack that we have selected in order to meet the fuel efficiency criteria. So it's this complex and commingled mess of technology, regulation, and self-regulation. Now, one of the things that you'll probably recognize is the fact that, let's say, for example, within API and ILSAC, there's generally a little bit of equivalence. So if we took the SN regulations as an example, they pretty much map onto GF5, where GF5 is SN plus a couple of extra tests. So it's SN plus some testing around turbo deposits, piston deposits, sludge control, and usually the ILSAC criteria are also more stringent on the fuel efficiency side. So you can always think of ILSAC as being the API plus a little bit extra. But then if we add additional testing on top of that when it comes to the OEM specs, it can get really confusing, right? We're getting all these names thrown at us. There's the VW, there's the Ford stuff, there's GM Dexos, BMW Long Life. All of these things can seem really, really confusing because there are just so many different specifications out there. You can really, really do your head in. So let's just take a couple of examples, right? And try and pare them down. Take the BMW specifications, for example. And there are many of them, but let's just take the basic ones. You've got BMW Long Life 01. What does this actually mean? Well, it's a full synthetic long life oil that generally meets the ASEA A3B3 specifications, as well as API SJ, plus, right, some emissions control criteria. Sorry, it's not emissions control, energy conserving criteria. What does that look like? Well, that looks a lot like SJ plus energy conserving gives you GF2. So we can sort of think of this BMW Long Life as being very much like ILSAC GF2. So with that in mind, the other thing that we have to remember is that ASEA A3B3 is now a defunct classification as of 2021. But the BMW Long Life is not defunct, and so it follows the old A3B3 criteria. So that can get a little bit confusing. All right, if we take a step up to BMW Long Life 01 FE, right? FE generally stands for fuel economy, and it is effectively the same specification, but with a lower high temperature, high shear viscosity. So if you'll remember, the A3B3 and the A3B4 criteria for high temperature, high shear was above 3.5 centistokes. BMW Long Life 01 FE moves you into an HTHS that's a little bit more similar to the A5B5 or the A7B7, but without the additional testing that comes along with those ASEA criteria. So, for example, A5B5 has an additional valve train wear test, and then with A7B7, there was testing around turbo deposits as well as LSPI. So we don't do those additional tests, but we do have the lower HTHS viscosity. All right, now let's look at something like BMW LL04. Well, that's a full synthetic long life oil with low SAPs, right? Which, remember, in the ASEA categories, puts us in the C categories, C for catalyst friendly, right? So BMW Long Life 04 is pretty simple. Now let's look at some of the GM ones. Dexos 1, for example, is a very, very stringent set of criteria. It is basically taking all the ILSAC GF6 sequence tests, but putting a much higher pass criteria on each of those tests. On top of that, there are GM-specific tests for things like aeration, LSPI, turbo coking, deposits, fuel economy, and wear. So there's a lot of additional testing that a lubricant has to undergo in order to meet Dexos 1. Now, it might seem a little bit counterintuitive, but Dexos 2 actually has far fewer criteria. So Dexos 2 is actually a low SAPs criteria that mostly mirrors a CSC3. And so if you look across the criteria, you'll recognize that BMW LL04 looks a lot like GM's Dexos 2. And often we can use these similarities to ensure that a single lubricant can meet many OEM criteria. So LL04 and Dexos 2 also look quite a lot like VW's 500, as well as Porsche C30, as well as ASEA C3. And so in general, we can use one formulation to meet all of these criteria. Now, some of the OEMs specify criteria at a specific viscosity grade. So maybe it only applies to a 5W30 or a 5W40 or something like that. But in general, you will see LL04, Dexos 2, one of the VW specs, a Porsche C30 and an ASEA a C3, and you'll generally see them all on the same formulation. And you can pass that out for different ones. So BMW LL01, that will match a whole bunch of different other OEM criteria. So the thing, I guess, as far as the takeaway goes from this, would be that there is a lot of overlap in the OEM criteria, but the OEMs are setting their own standards because they want very specific tests that can suit the technology stack that they have chosen in order to meet various emissions criteria.